In this question, we have a golf ball projected over T with a speed of 30 meters per second at an angle of 50 degrees above the horizontal. Assuming level ground, we have to calculate the total time the ball is in the air and then find the horizontal range. So before I do the question, I'm going to restate it in simple terms. So for part A, I have to calculate the time to get to the peak and then add the time to come down to it. And when you add the two times, you will get the total time the projectile is in air. And for part B, I have to calculate the total x displacement. That is the horizontal range. And before I do anything, I'm going to visualize the problem. I'm going to start with the diagram. First, I'm going to show the x-axis and y-axis, and then I'm going to use a line diagram to show the trajectory of the projectile. And then I'm going to define the positive x-axis to the right and then positive y-axis up. Initial x position is 0. Final x position is an unknown. That's what we are trying to calculate. Initial y position is 0. Final y position is also 0 because it's at the same height level. And initial speed is 30 meters per second, and the angle between the initial speed and the x-axis is 50 degrees. And this is the vector triangle, so we have to solve for the initial x component of the velocity and the y component of the velocity. When you do that, look at this. So this is a right triangle. You have to use your knowledge on trigonometry to solve for the x and y components. So V naught cosine 50 is the x component. Y component is V naught sine 50. 50 degrees is the angle between the x component and the hypotenuse of the triangle. And now I'm going to identify the knowns and unknowns in x direction and y direction. And before that, let's see, time is a scalar quantity. It is independent from the direction. It is common for both directions. So that is also an unknown. And then let's see the components in x and y direction. We know that initial x velocity is equal to final x velocity because the acceleration in x direction is just 0. And you should have a constant non-zero velocity in x direction. And in y direction, initial y velocity is 23 meters per second. Final y velocity should have the same magnitude by symmetry, but it is negative. The reason is the velocity, final velocity is downwards. When the projectile is reaching the ground, the final y velocity is downwards. We have up as positive, down as negative. And then I have identified the positions, initial x position, final x position, and then y positions, and then acceleration in y direction is negative 9.8 meters per second per second. Again, let's see the variables in x direction. What we are trying to solve for. We are trying to solve for the time. Time is measured in seconds, and then it's positive, and then x position, final x position is measured in meters. It's positive because initial x position is, you can see it on the diagram, and final x position is right to the initial x position. So we have defined right as positive. Final x position has to be positive for that reason. And now let's plan the solution. When you plan the solution, you have to identify equations in x direction and y direction separately. And in y direction, I'm going to use this equation because I know everything in this equation except for the time. So I can use this equation to solve for the time. And then let's look at the equation in x direction. There's only one equation in x direction. And if you look at this equation, there are two unknowns. We don't know the final x position, and also we don't know the time. But time is common for both directions. Once you solve for the time from the equation in y direction, you can use that time in your equation in x direction. Okay? So now let's execute the plan. So once you have a plan, it's really easy to execute it. Use the equations for x direction and y direction separately. And for the x direction, I'm going to first do it for the y direction because I have to solve for the time first. Final y velocity is negative 23 meters per second. And then that would be equal to initial 23 meters per second plus negative 9.8. Again, it's negative because we have acceleration due to gravity downwards, and we have defined up as positive. And you have to rearrange the equation. You have to subtract 23 from both sides of the equation, and you get negative 46 on left hand side, and then you have negative 9.8 on the right hand side of the equation, and then you have to divide both sides by negative 9.8, once you do that, you get negative 46 meters per second divided by negative 9.8 meters per second squared. And then meters to meters cancel out, and then seconds will cancel out with seconds squared, and then you still have 1 divided by 1 over second, and reciprocal of 1 over second is just seconds. So you get the answer 4.69 seconds as the time. This is the total time the projectile is in air. And now I'm going to use the equation for the x direction, and just doing the substitution for the initial x velocity, I got 19.2. That is v naught cosine 50. 30 cosine 50 is 19.2 meters per second. And multiply that by time, and then seconds to second will cancel out. You get 90 meters for the horizontal range. Okay. .90 meters for the horizontal range. Okay, so now let's see an alternative method. So the alternative method is you can use another equation to solve for the time. If you consider initial y position as the launch point and final y position as the maximum height above the ground, you can use v is equal to v naught y plus ayt, the same equation we used earlier, to solve for the time taken to reach the maximum height. And then you can multiply that by 2 to solve for the total time taken to reach the ground. Final y velocity is 0 because we are going to take the final position as the maximum height level. And when you solve for the time, you get 2.346 seconds. And then total time is 2 times that. It is 2 times 2.346 by symmetry, because it takes the same amount of time to reach the maximum height level and come back to the final position, because initial y position and final position are at the same height level. Okay, now let's see the steps. We visualize the problem first, identify the knowns and unknowns in both directions. And then time is a scalar quantity common for both sides. And then we looked at the equations for x and y direction separately, and then we executed the plan for the x and y direction separately, solve for the time, use that time to do the calculation in x direction. Now we have solved for the time and the horizontal range. The signs are correct, we got positive. Yes, they have the correct units, and then the magnitude of the answer reasonable. It takes about 5 seconds to reach 90 meters in x direction. Yes, it makes sense.